Every now and then you find a piece of code that's, it's more than just a tool. It's a mystery box. And today, we're going to pry one of those boxes open. It's a self-contained Python script called the Ethereum Hub, and it feels like it was designed for some really specific and frankly, really strange research. Okay, let's dive in.
And boom! Right at the top of the file, we find our central mystery, a single cryptic comment, assembled for the witness, you. I mean, who is the witness? Is it supposed to be us, the people looking at the code right now, or is it for someone or something else entirely? That one question is going to hang over everything we see today.
So, to really get what's going on inside this thing, we've got to take it apart piece by piece. First, we'll look at what the toolkit actually is. Then we'll dive into how it creates these weird data things it calls weaves. After that, we'll see how it analyzes them, how it remembers what it finds, and finally, how it can do this entire process all by itself.
All right, so let's start with the 10,000-foot view. What exactly is this Ethereum Hub?
In a nutshell, it's like a whole digital laboratory packed into a single file. Seriously, it's built to generate these complex streams of numbers, then turn around and analyze them for hidden patterns, store what it learns in a searchable memory, and, get this, it even has these little autonomous agents that can automate the whole research cycle. It's an incredibly powerful system, all wrapped up in one script.
Okay, let's get to the heart of the machine, how it actually creates its data. The toolkit has a special name for these unique sequences. It calls them weaves.
The core of this whole operation is a class called Ethereum Weave. The best way to think about it is like a factory, but instead of churning out cars or widgets, its entire purpose is to produce these incredibly intricate patterns of numbers, all based on different rule books and starting ingredients.
Now, what's really interesting is how it classifies its methods for making these weaves. It uses a biological term, phyla. Each phylum is basically a unique recipe. Just like a chef has different recipes for different dishes, the Ethereum Hub uses different phyla to generate weaves that are just wildly different from each other.
And believe me, it has a whole cookbook of them. You've got phyla that are super predictable, like position dependent, and then you have others that are way more chaotic. There are methods here based on evolution, fractals, even on the data's own environment. This is so much more than just random number generation. This is systematic, deliberate pattern creation.
To really get a feel for the range here, let's put two of these side by side. On one hand, you've got the position-dependent phylum. This is like a little mechanical music box. It just combines two fixed lists of numbers over and over to create a predictable repeating pattern. But then you have environmental dependent, which is more like a weather system. It's constantly measuring the randomness of what it just created and then changes its own rules on the fly. It's just a brilliant example of how this toolkit can produce both simple order and really complex emergent behavior.
Okay, so the toolkit can generate these complex weaves. But creating data is only half the battle, right? The real trick is understanding it, finding the hidden order in all that chaos.
One of its most interesting analyses tools is something it calls the folding trajectory. Let me walk you through this. It takes a long sequence of numbers, literally folds it in half, and adds the numbers at each end together. This makes a new, shorter sequence. Then, it does it again, and again. The whole point is to see if, as you keep folding, a stable, hidden pattern emerges, or if the whole thing just dissolves into nothing. And after it's done all that number crunching, the toolkit gives you this neat little summary with some pretty fascinating metrics. I mean, it goes way beyond the basics. It's measuring the randomness of a sequence with something called entropy, and even its prime underscore density. This tells us it's not just looking for any old patterns, it's looking for very specific, maybe even unusual, mathematical properties.
So, we've got data generation and data analysis. But for this to be a real research tool, the system needs to be able to remember what it learns. And that's where the next layer of this toolkit comes into play. It handles this with a component called a simple vector store. Honestly, the easiest way to think about this is as the system's brain, or maybe its own internal library. Every analysis it runs, every little pattern it finds, it gets logged and stored right here so it can be looked at later.
So how does this memory even work? Well, it's pretty clever. When a new piece of information is added, it's first converted into a string of numbers. That's called a vector. This process is called embedding. And what this does is it allows the system to search its memory not by keywords, but by conceptual similarity. It can ask questions like, hey, show me other weaves that had a similar vibe to this one and get really relevant results. And it can even save its entire memory to a file so it can learn across different sessions.
Generation, analysis, memory, all the pieces are on the board. And now we get to the final and maybe the most impressive part of all. This toolkit can run the entire research process completely on its own.
It pulls this off using a multi-agent system. You have a Weave agent that's in charge of making and analyzing the data. Then there's a data agent that manages the memory. And watching over all of them is the orchestrator, which is basically the project manager telling the agents what to do and when to do it.
And this workflow here, it's a perfect automated loop. The orchestrator tells the Weave agent, go make a new pattern. The agent does, then analyzes it. The results get handed off to the data agent, which sticks them into the memory, and then, and this is the kicker, the data agent immediately turns around and queries the memory, asking questions about the very data it just saved, maybe trying to find connections to things it's seen before. It's a totally self-contained, self-improving discovery engine.
So, we've unpacked the mystery box. We've seen this incredibly powerful engine for creating and analyzing complex patterns, and it's even got a memory and an autonomous workflow. We know how it works now, but that just throws us right back to those bigger original questions. What is this incredibly specific, sophisticated tool actually for? And if this whole thing was assembled for someone, just who or what is the witness?